Kinematics, I think 6th lecture, 5th lecture. Kinematics 5th lecture. I'm doing type 6 today, that is the last type of kinematics. It's termed as, pay attention now, it's termed as relative motion. I'll give you some points. After that we can write. First point. Relative means to subtract or subtraction. Relative means to subtract. Second point. In case of one dimension, use proper signs. Means what? It's going towards right, it is plus, and it is coming towards left, it is minus. Down it is minus, up it is plus. So whatever you set up in your mind, that is very important. That this direction is plus, is minus. This direction is minus, this direction will be plus. See, in case of 2D, use vector method. Vector method means what? 2D or 3D also. Vector method means concept of I cap, J cap and K cap. D point. How to explain relative motion? Suppose there are two persons. One is a tall person of 6 feet. Other is a short person of 3 feet. A and B. If I ask, what is height of A with respect to B? Height of A with respect to B means I am asking B, according to you, how much A is taller? Formula is in relative motion means subtraction. So it will be height A with respect to B. It will be HA minus HB. So HA is 6 minus 3 will become 3 feet. So height of A with respect to B. So B is looking at A and he is setting up, this is the reference. His reference is this. So when he looks at A, he tells that he is 3 feet taller than me. Similarly, if I ask, what is the height of B with respect to A? It will be HB minus HA. HB is 3 minus 6 will become minus 3 feet. That means height of B with respect to A means B is looking at A. Oh, sorry. A is looking at B. A is looking at B and telling that he is 3 feet shorter than me because his reference is this. So he's 3 feet shorter, no? And according to this guy, he's 3 feet longer. So it depends on what reference you set up. I'll give you some other examples also. Listen over here. Example 1. Look over here, no? There are two cars. One is going with 2 meters per second. And other car is going with 6 meters per second. This is 1 and this is 2. I want to find velocity of 1 with respect to 2. Means who is looking at whom? Velocity of 1 with respect to 2 means 2 is looking at 1, and we are asking 2 that according to you, which speed is he going by? It will be different because these speeds are according to us, which we are there on the ground. So this speed is with respect to ground, this speed is with respect to ground. But they have asked you velocity of 2, 1 with respect to 2. Now it will be relative mean subtraction will be V1 bar minus V2 bar. What is V1 bar beta? 2 meters per second. What is V2 bar beta? 6 meters per second. It will become minus 4 meter per second. What do you mean by this? Okay, it means, pay attention over here. It means that 2 is at rest. He's at rest. Car 2 is at rest. And car 1 is going with a speed of 4 meter per second according to him. That's why I find out now velocity of 1 with respect to 2 means in your mind you stop 2. This all is happening in your mind. In your mind you will stop 2 and you will see that 1 is going where. So 1 will go with minus 4. Minus means that direction. 1 is going in that direction with a speed of how much? 4 meter per second according to 2. Actually they were moving this way. But when he looks at him, he is appearing to go back with 4 meters per second. Are you getting it? Please stop writing a lesson over here. Next thing. If I want to find velocity of 2 with respect to 1, it will be V2 bar minus V1 bar. What is V2 beta? 6. Minus V1 bar is what? 2. Is what? 4 meter per second. V2 1 bar. Who is looking at whom? Velocity of 2 with respect to 1. Who is looking at who? 1 is looking at 2. So you will assume in your mind that 1 is at rest. So this 1 is assumed to be at rest. And when this guy looks at 2, it appears to him that he is going with what? 4 meter per second towards the right. See, it appears to him for this way. It appears to him for this way. So actually, can I say V1 2 bar and V2 1 bar are equal and opposite? Were the cars traveling in the same direction or in the opposite direction in the original diagram? Same direction. Always remember the concept. Same direction. Subtract. Subtract. No? 6 minus 2 is what? 4. So it will appear to him that he will go away with 4, and it will appear to him that he will also go away with 4. The rule is same direction subtract. It will appear to him that he is going with 4. It will appear to him that he is also going with 4. Because if this is plus 4, this has to be minus 4. Velocity of 1 with respect to 2 means who is looking at whom? 2 is looking at 1. Whoever is looking is assumed to be at rest. V21 bar means who is looking at who? 1 is looking at 2, because this is velocity of 2 with respect to 1, with respect to 1, with respect to 1. So who is looking at who? 1 is looking at 2. So 1 is assumed to be at rest. Are you getting it? What's happening? Now, next example. Look over here now. Pay attention, please. Pay attention. You write it as a whole later on. Suppose there are 2 cars. V1 is 2 meter per second. And V2 is 4 meter per second. They are coming towards each other. They were going in the same direction. This is going in the opposite directions. Pay attention. What do you mean by velocity of 1 with respect to 2? Beta will be V1 bar minus V2 bar. V1 bar is this way, that is 2. 2. Minus V2. What is V2? 4 or minus 4? Minus 4, because it is going that way and you have to substitute proper sign. So it is minus 4. So answer will become what, beta? 6 meter per second. Now you tell me who is looking at who? Velocity of 1 with respect to 2 means 2 is looking at 1. So in my mind I will stop 2. So can I say V2 is 0? And he is appearing to go where? With 6 meter per second. So can I say this will become how much, beta? 6 meter per second. This is what? Velocity of 1 with respect to 2. Means when this car looks at this car, the person in this car looks at this car, it appears to him that this guy is coming near with 6 meter per second. Getting it? Similarly, if I tell you what will be V21 bar, you will tell me, bacha, it will be V2 bar minus V1 bar. What is V2 bar? V2 bar is minus 4. Minus V1 bar is plus 2. What will become? Minus 6 meter per second. Can anyone tell me who is looking at who? Velocity of 2 with respect to 1. So who is looking at who? So whoever is looking, stop him. Means V1 will become what, bacha? 0. And 2 is going with minus 6. What do you mean by minus 6? That way? Can I say this is the velocity of 2 with respect to 1 is how much, beta? 6 meter per second. Minus matlab aise. This direction 6. Okay. So they are appearing to come near. They are appearing to come near. They were appearing to go away. What is the rule over here? Opposite direction. Add. See na? 4 plus 2? 6. So you stop him. So 6. You stop him. So 6. So what is the rule over here? Opposite direction. What to do? Add. Same direction subtract. Opposite direction add. Did you get this concept? Same direction just subtract. Thina? 6 minus 2 is how much? 4. So it will appear to him he is going 4. It will appear to him he is going 4. 2 plus 4, 6. It will appear to him coming with 6. It will appear to him coming with 6. Same direction subtract. Opposite direction add. Write some questions. We'll do it. Example based on relative motion, right? First question, acceleration of two particles are 2 meter per second and 3 meter per second. 2 meter per second second square and 3 meter per second square along negative x direction. Along negative x direction. Find A12 bar and A21 bar. A12 bar and A21 bar. Listen to me. Acceleration of two particles are 2 meter per second square and 3 meter per second square along the negative x direction. So can I say A1 is minus 2 meter per second square? Negative x direction. To take proper signs. A2 will become minus 3 meter per second square. Negative x direction. Find A12 bar. You know A12 bar will be A1 bar minus A2 bar. A1 bar is minus 2. Minus or minus 3 will become plus 3 will become plus 1 meter per second square. Now you can say that who is looking at who? 2 is looking at 1. So whoever is looking, his acceleration will be 0. And this guy 1 is appearing to coming near with 1 meter per second square. This is acceleration of 1 with respect to 2. Is that rest? Will come near. Yes or no? Plus 1, no? This way. Can anyone tell me what will be A21 bar? A21 bar will be minus of A12 bar. That will be minus 1 meter per second square. That means who is assumed to be at rest? 1. And the second one is going there with minus 1, means 1 meter per second square towards the left. This is the acceleration of 2 with respect to 1. Getting it? Copy. Next question. Velocity of 1, right? Velocity of 1 is 3 meter per second. 3 meter per second towards east. Velocity of 1 is 3 meter per second towards east. And velocity of 2 is 4 meter per second towards north. Towards north. Find V12 bar and V21 bar. Now listen to me, please pay attention. Can anyone tell me, is this one dimension sum or two dimension sum? If you listen, it's 2D sum. So we know that these are the directions: east, west, north, south. East, west, north, south. If you are looking towards the north, your right hand will be towards the east. Always remember this thing. Looking towards the north, your right hand will be towards the east. Same way over here. Okay. Now they are telling you that V1 is 3 meter per second towards east. So V1 bar is this way. 3 meter per second due east. Car is going this way. and velocity of 2 is 4 meter per second towards north. Second car is going this way. Getting it? I want to find velocity of 1 with respect to 2, and similarly velocity of 2 with respect to 1. Pay attention over here. Now this was by an observer who is observing from outside the frame. You are looking, one car is going this way, other car is going that way. But they are telling you that what is velocity of 1 with respect to 2. When a person inside this car looks at him, will he appear to go this way? No. He will appear to be going somewhere this way. And when he looks at him, he will not appear to go that way. He will appear to go that way or that way, wherever. We don't know. Are you understanding? We are looking from the frame outside on the earth. You can imagine two cars are going, no? But when one car looks at the other car or other car looks at this car, what will be the situation? Now we need the solution. Pay attention. Can I say V12 bar will be V1 bar minus V2 bar? Bacha, V1 bar is 3. Can I call this I cap? X-axis is I cap. Minus V2 is 4. But along this way, it is J cap. So they are telling you that V12 bar is 3 I cap minus 4 J cap. 3 I cap minus. Now I have to plot this in the parallelogram law. Pay attention how to do it. Okay. You can do it either by triangle law or by parallelogram law. I am doing by parallelogram law. You can try it by triangle law at home. How it is. This is the thing. East, west, north, south, same thing. East, north, west, south. 3 I cap if I want to draw. This is 3 I cap. 3 na? 3 I cap. Correct na? This is what? East, west, north and south. And if I want to plot minus 4 J cap, so 4 J cap is up, but minus 4 will be down. So minus 4 J cap. Minus 4. 4 magnitude down means minus 4. Yes or no? It's 3 I cap minus 4 J cap. Now out of this I will draw a parallelogram. Sir, why are you drawing the parallelogram? Because two vectors ka tail are joint. If the head of the first will be joining the tail of the second, you can draw a triangle. But in a parallelogram law, the tails of the two vectors are joined, they are meeting at the same point. Remember? Who gives you the resultant? The diagonal, which is also passing through the same point. Can I say this is V12 bar, which will have magnitude as well as direction, and the direction will be given by this angle. Remember, V12 bar. Can anyone tell me how to calculate magnitude of this? You know it. So magnitude of V12 bar, we know it from scalar vectors. It will be root of 3 square plus 4 square. The answer will be 5 meter per second. Means this magnitude is bacha 5 meter per second. Now we need to calculate the angle also, because this is adha adhura, na? This is what? Only the magnitude. The vector is known by magnitude as well as direction. Now can I calculate tan alpha from here? For tan alpha will be 4. This is 4. So this will also be 4. 4 by 3, na? So alpha is going to become tan inverse of 4 by 3. Now remember something I am teaching you. There's a triangle. which is very famous for your entrance examination, is the 3, 4, 5 triangle. Three, 4, 5 triangle. This angle is 37 degree always. Opposite to 3. 37. This is 90. This angle will be 53. Always remember 3, 4, 5 triangle. Opposite to 3 is 37. Now you know that tan 53 is how much, bacha? Tan 53. What is tan 53? 4 by 3. So what is tan inverse of 4 by 3? 53. So that means this angle is how many degree? 53 degree. You should know this triangle. Opposite to 37 is 3, opposite to 53 is 4, and opposite to 90 is 5. So if you remove, you get that answer. Now it is the time to write the answer. Can I say V12 bar is 5 meter per second? Magnitude 53 degrees south of east. 53 degree south of east means you are standing in the east, and if you go 53 degrees towards south, the answer will come. Again, where are you? East. If you go 53 degrees south, the answer will come, no? So this is also termed as 53 degrees south of east, or it can also be written as 37 degrees east of south. This is very much necessary because out of the 4 options, this something is given, and if you don't know to analyze, you will not be able to get only. You will get the answers also, but you will not be able to get this. 53 degrees south of east or 37 degrees east of south. This is first answer. Now they have asked you V21 bar also. Very simple it is. You know V21 bar is minus of V12 bar. Means if V12 bar is this, bacha, the vector opposite to this will be what? V21 bar. And this is alpha. So can I say this is also alpha? And this magnitude will be 5 only. And alpha will be how much? 53. Can I say what is V21 bar? Can anyone tell me? V21 bar ka magnitude is 5. 53 degrees north of west or 37 degrees west of north. But I'll write 53 degrees. What? North of west. Did you understand? Write this down fast. Right. Applications of relative motion. Applications of relative motion. First application, sums based on collision. Sums based on collision. Second, rain umbrella problems. Rain umbrella problems. Third, river boat problems. River boat problems. Fourth, escalator problems. And fifth, aircraft wind problems. Aircraft wind problems. Aircraft wind problems. So today we will be discussing the first type. I will take one more lecture on relative motion where I will be discussing all the types. Getting it? After that, major exam will be there based on motion in one dimension. We have to remember all the 6 types. You know, the first type was based on uniform motion. There was only one formula: speed is distance upon time. All the types you have to remember. Second type was accelerated. We are using V is U plus AT, S is UT plus half AT square, V square is equal to U square plus 2AS. Third type was non-uniform motion. We differentiate and integrate. Integration I have not taught you right now, it will be at a later stage. Fourth type was graphical section. Fourth type was collision types. Where do they meet? Last time we had done. The fifth type was graphical type. And the sixth type is relative motion. Are you all understanding? So if you remember the types, things become very easy for you. First, sums based on collision. We are going to start applications of this question. Now, listen. Application 1. Collision sums. Pay attention. If I give you a sum directly, that example 1. There is first body going up with 40. Second body coming down with 10 meter per second. The distance between them is 100 meter. Distance between them is 100 meter. Question is, what is the time for collision? Find the time when they collide. This same sum, we had done it in type 4. Where do we consider it to meet? Up. S1, S2. I have written S1 is S2 plus 100. Those who have practiced, they must be knowing. And we just apply S is UT plus half AT square, S is UT plus half AT square, and you will get the answer. Sums where one body was left later than the other body. This same sum I am going to solve by relative motion method. Relative motion method, not by absolute. That method was termed as absolute method. What? Absolute method. We can know this also. Can I say V1 2 bar? Beta, look over here. It will be V1 bar minus V2 bar. Relative motion, no? What is V1 bar? Plus 40. Minus V2 bar minus 10. Substitute proper sign. Will become what? 50 meter per second. Who is looking at who? 2 is looking at, and it is appearing to 2 that 1 is going up with 50. I'll draw the diagram now. Can you tell me what is acceleration of 1 with respect to 2? It will be A1 bar minus A2 bar. Now what is acceleration of 1 in gravity? G, na? And what is the acceleration of 2 also? G. So can I say both are down? So same direction subtract will become G minus G will become what? 0 meter per second square. This same direction. Now if I draw the diagram, this is my absolute diagram from the point of view of outside. But right now we are saying that 2 is looking at 1. So we have assumed that 2 is at rest. 1 is going up with a speed of how much beta? 50. According to him, na? And the displacement distance between them is how much bacha? 100. And this is which motion now become? Uniform motion or accelerated motion? Uniform, because A has become 0. A has become, so the relative acceleration of them becomes 0, means it will be converted into which motion? Uniform motion, means sums based on type 1. There is only one formula. Speed is distance upon time. What is the speed? 50. What is the distance between them? 100. So what is the time? So can I say they collide after 2 seconds? They collide after 2 seconds. Did you get this concept? Yes. Write this down. You can solve this at home by absolute method also. You will get the same answer. Next sum based on collision types by, you can solve this by absolute method also. Where do they meet? You assume them meeting here, and the distance between them is also given. It's 20 meter. You can assume them meeting here. Can I say S2 plus 20 is S1? Then you apply S is ut plus half t square, S is ut plus half t square, and take their proper signs. This direction will be plus and this direction will be minus. So according to that you can solve also. That is absolute method, but I am solving over here by relative method. Can anyone tell me what is velocity of 1 with respect to 2? It will be V1 bar minus V2 bar. Pay attention over here. V1 bar is minus 2 minus V2 bar is 6. That is minus 8 meter per second. Look now. V1 minus 2. V2 6. So minus 2 minus of 6 will become minus 8. Who is looking at whom? 2 is looking at 1. Can anyone tell me what is the acceleration of 1 with respect to 2? It will be A1 bar minus A2 bar. A1 bar is plus 4 minus A2. A2 is minus 2. It will become what? 6 meter per second square. Now the new diagram. The new diagram. Pay attention now. So this diagram will be, right now we are stopping whom? 2 is at rest. 1. Bacha, velocity is minus 8. Minus 8 matlab 8 meter per second in this direction. And 6 meter per second square is the acceleration this way. Bolo. And the distance between them is how much better? 20. Now is this uniform motion or accelerated motion? Accelerated motion. Can I use S is equal to ut plus half at square? S is 20 plus 20. U is bacha minus 8. T I don't know. Plus half A. A is plus 6. T square. So can I say this will be 3t square minus 8t minus 20 is equal to 0. So A will become 3, B will be minus 8 and C will be minus 20. So T is going to become minus B plus minus root of B square minus 4A C upon 2 3s are 6. Right now 2A. So this is going to become plus 8 plus minus 64. The 8 3 are 24. 24 64 will become root 304 by 6. Minus will not come because time cannot be negative. That is before motion. We are understanding the future. So we will take plus. So time will become plus 8 plus 304. Can I take that 300? 300 is 10 root 3. Root 3 is 1.732. Into 10 will become approximately 17.3 or 17.4, right? Divided by 8, 6. 18 plus 8 is what? 25.4. divided by 6, approximately the answer will become 4.2 seconds. This is the time of what beta? Collision. Did you understand?